In case of digital electronics, there are only two levels of voltages, 0 level and 1 level. 0 level means 0 volts, 1 level means 5 volts. Logic gates are the basic building blocks of digital electronics. There are different types of gates: NOT gate, AND gate, OR gate, NAND gate, NOR gate, XOR gate. Such gates are there. Gate has one or more inputs but only one output. It has only one output. Whenever there are digital relationships between input and output, these input-output relationships are given by a special algebra known as Boolean algebra. Boolean algebra is developed by one mathematician, statistician, George. Using this algebra, input-output relationships in digital electronics can be given. In that, the NOT, for the NOT, bar is used over the variable. In case of AND, dot is used. In case of OR, plus sign is used. But this plus is not same as the addition. Now let us study one by one gates. First consider NOT gate. NOT gate is also known as inverter. From the name itself, NOT, it is clear that output is not same as input, but it is exactly opposite. So on one side there is input, only one input the NOT gate has and one output. Then if input is 0, the output is 1. If input is 1, the output is 0. Let us call the input as A and output is Y. Then all the possible values of A and Y, they are given in a table known as truth table. Truth table is a table which gives all possible input outputs in a digital circuits. Here there is only one input and there is only one output. But as we go ahead, there could be many inputs and many outputs also. So if A is 0, Y is 1. If A is 1, Y is 0. This is the inverter. Now using Boolean algebra, this is given as Y equal to A bar. Bar means opposite of A. So when A is 0, Y will be 1. When A is 1, Y will be 0. If you use two inverters, for example, this is one inverter, this is another inverter. This is called as bubble. This circle is called as a bubble and this bubble indicates inversion. Bubble indicates inversion. So if A is here and Y is the output of first NOT gate and X is the output of second NOT gate, then we will write X is equal to Y bar, Y is equal to A bar. Now if A is 0, Y will be 1 and again X will be 0. If A is 1, Y will be 0 and X will be again 1. So here we understand that X is equal to Y bar, but Y is equal to A bar. So A bar bar. So A bar bar is A. So single bar means inversion, double bar is known as buffer. AND gate. This is the symbol of AND gate. AND gate can have 2, 3, 4, many number of inputs. So let us call A as first input, B is second and Y is the output. Now AND gate has following truth table. Truth table. If you write truth table, then in truth table there will be inputs and output. For a gate there is a single output, but whenever we will design a digital circuit, it may have more number of outputs also. So inputs are A and B, output is equal to Y. How the AND gate is? From the name itself AND, it is clear that when A and B both are high, high means 1, then only output is equal to, output Y is equal to high. If any of A or B or both are 0, then Y is equal to 0. So when A is 0, B is 0, Y is 0. If this is 0, this is 1, still 0. If this is 1, this is 0, still 0. When both are 1, then only the output is 1. This can be understood with a circuit. Suppose battery is here. Then there is a switch. This switch, let us call it as A. This switch, let us call it as a B. And here is a lamp. Now consider that if A is closed but B is open, bulb will not glow. If B is closed but A is open, still bulb will not glow. But when A is closed and B is closed, then only the current will pass and bulb will glow. So both must be high to get the output high. If any input low, the output will be low. This AND gate is given by the Boolean algebra as Y is equal to A dot B. Y is A dot B. Dot is the symbol used for ANDing. Now here we understand that 0.0, 0.0 is 0. 0.1 is also 0. So from this we understand that if we dot anything with 0, then the output is 0. So if you have AND gate whose one input is 0, then output will be always 0. Suppose A dot 0 we take. Then if A is 0, still the output is 0. If A is 1, still the output is 0. So A dot 0 is always 0. Now consider 1.0 is 0. 1.1 is 1. So if you AND with 1 any input, if you AND with 1 any input A, then from this you understand that A dot 1 if you take, then if A is 0, the output will be 0. If A is 1, the output will be 1. So A dot 1 is A. Okay. Now consider A dot A bar. If A is 0, A bar is 1. So 0.1, the output is 0. If A is 1, A bar is 0. So again 0. So A dot A bar is always 0. A dot A. What will be A dot A? If A is 0, both are 0. So output is 0. If A is 1, both are 1. So output will be 1. So whatever is A is A. So if for AND gate, if you connect both the terminals together, then it just acts as a buffer that output is same as input. So Y is equal to A in this case. If the AND gate has three inputs, A, B, C and Y, then how the truth table will be? Truth table A, B, C and Y. When there are two inputs, there will be four combinations 0, 0, 0, 1, 1, 0 and 1, 1. Because every input can be 0 or 1 only. Now here these are the inputs and Y will be the output. When there are three inputs, there will be 2 raised to 3. 2 raised to 3, that is 8 combinations. What are these 8 combinations? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Now here in case of AND gate, if all the inputs are high, then only the output is high. If any 1, 2 or all inputs 0, the output is 0. So here all the output is 0. This is the output of AND gate. In case of multiple inputs, if all the inputs are high, then only output is high. If any input 0, the output is 0. Exactly opposite to AND is NAND gate. Let us consider NAND gate now. NAND is not AND. Not AND. So its symbol is first AND and then inversion. So this is NAND. So A, B and Y. How it is written through the Boolean algebra is first the AND operation is done and then the inversion is done. So AND operation is A dot B and the inversion so bar. So this is the Boolean equation for NAND gate. How the truth table of NAND gate will be? Inputs A and B, output Y. So 0, 0, 0, 1, 1, 0, 1, 1. Now try to remember the AND output. In case of AND, when 1 1 it was 1. Now this is not AND, so in case of 1 1 it will be 0. In case of AND, in all the first three cases the output was 0. Now it will be inverted, so 1 1 1. This becomes the truth table of NAND gate. NAND is exactly opposite to AND gate. Now consider OR gate. From the name itself OR, it is clear that A or B. This is the symbol of OR gate. There are 2, 3, 4, any number of inputs there can be, and if any one of them is high, the output is high. So if A is high, still output is high. If B is high, still output is high. If both are 0, then only the output is 0. So let us write down the truth table. A and B are the inputs. Y is the output. 0 0 0 1 1 0 1 1. OR is such that if any one or all inputs are high, then output is high. If all inputs are 0, then only the output is 0. So here 0 0 generates 0. This is 1, this is 1, this is also 1. The Boolean equation is y is equal to a plus b, but see here that it is not addition, because 1 plus 1 in normal addition it becomes 2, but here 1 plus 1 is 1 in Boolean algebra. Y is equal to a plus b. This can be understood with the simple circuit that suppose this is a battery and this is one switch, this is another switch, and there is a bulb. Suppose this switch is A, this switch is B. Then if A is closed, still the circuit is complete. If A is closed, still the circuit is complete. If B is closed, still the circuit is complete. When both are open, then only the circuit is incomplete and bulb will not glow. If any one of A, B or both are closed, the circuit is complete. Now here from this we understand that from the truth table, 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1 is also 1. Now from this, from the first two, we understand that if you add 0 plus 0, we get 0. And 0 plus 1, we get 1. So if this is A, then A plus 0. If A is 0, then 0 plus 0, the output is 0. If A is 1, 1 plus 0, the output is 1. So A plus 0 becomes A. From these two equations, we understand that if we OR with 1, then whatever is the another input, the output is 1. So A plus 1, the output is always 1, whatever is value of A. If A is 0, 0 plus 1 is 1. If A is 1, 1 plus 1 is 1. So A plus 1 is 1 always. Now consider A plus A. A is 0, then 0 plus 0, the output is 0, so A. If A is 1, then 1 plus 1, the output is 1, again A. So A plus A is A. A plus A bar. Consider A plus A bar. If A is 0, A bar will be 1, so output is 1. If A is 1, A bar will be 0, the output will be 1. So A plus A bar is always equal to 1. A plus A bar is always equal to 1. NOR gate is exactly opposite to OR gate. So it is not OR. Symbol of NOR gate is OR gate and then inverter. So it may have the inputs, any number of inputs, A, B, C, etc. So A, B are the inputs. Now not OR. So the output of OR and then inversion. So let us draw the truth table. A, B and Y for NOR gate. Then 0, 0, 0, 1, 1, 0, and 1 1. So in case of OR, 0 0 was 0. So here it will be 1. In case of OR, 0 1, 1 0 and 1 1. Both were 1. So here it is 0. So in case of NOR, if all inputs are low, then only output is high. If any input is high, then output is low. And Boolean algebra gives y is equal to NOR. NOR means OR and then bar. So this is the Boolean equation for NOR gate.